I've been repairing a Moog satellite. I say repairing instead of restoring, because I really could care less about restoring it. I just want it to sound great. To get where I've gotten so far, I've had to repair the power supply. Basically replace all the ICs. Add an IC socket. Replace numerous transistors. Maybe a capacitor or two. And I still have a ways to go. But I want to play it for you now. So here is the best Moog satellite you're ever going to hear. It's a little heavy on the pulse rate modulation there. So, you're wondering, like any sane person would be, how do I get myself a Moog satellite? I can't believe it sounds like that. Well, you're sort of right. You were not hearing a Moog satellite. I was using the Moog satellite as a CV controller. And that's what this video is really about. So, the satellite uses a 3 volts per octave scheme, which is a little unusual. Most synthesizers, especially Moogs, use 1 volt per octave. So I rigged up an extremely simple voltage divider, a tunable voltage divider. In fact, it's just a 100 kilo ohm resistor and a 1 meg pot, using a handy dandy E-Tech City voltmeter. I was able to tune it. Since you've got 3 octaves and it naturally goes from negative 4.5 volts to positive 4.5, you simply need it to go from negative 1.5 to positive 1.5. That's really easy to check. And since I'm rebuilding this Moog anyway, I know quite a lot about its circuitry and where the different points are to get the signals that I need. Turns out that pins A4 and A9 give me keyboard voltage to ground. Then running those through my simple voltage divider and tuning it so that I get a spread of 3 volts, i.e. low C gives me negative 1.5 and the high C on this keyboard gives me about a positive 1.5. I could tune it a little better, but you just heard it and it's tuned pretty well. So now, what am I doing with that CV signal? Well, here's what you were hearing. I'm sending this to a Moog Workstot. Now, the Workstot is an interesting little synthesizer. It has something labeled Gate Out. Gate Out also works as Gate In. But I'll be honest, I'm not sending a Gate In signal from the satellite keyboard. You could do that. It would take a little more effort. I think it's a negative going signal and the Workstot wants a positive going signal, so I'm just not dealing with that. Instead, I turned up the LFO all the way. When you turn up the LFO all the way and put it in square mode and then patch the output back into the gate, you get that. You get whatever pitch you're playing. I can override that by using the CV in. The CV in is what I'm getting from the satellite. And you see, you still get the note of the Moog. So I tried to play legato, or if I just hold 2 notes down. So there you go. Moog work stop. Controlled with a 1 volt per octave control voltage keyboard. So what this really is this is a prototype in my mind of what I'm going to do with this satellite if I can't get it working right. I will just turn it into a CV controller. And it's not just CV that you can get off of it. So you can get the pitch. I can figure out ways to get the trigger. And you can definitely get LFO. So on a satellite, what you've got is square waves and sine waves. You can't see the control plate. Actually, maybe I have it around here. Oh, here's the control plate. So on the control plate, you can control rate and depth of modulation. And it's easy to tap into the modulation circuit and send that circuit off to the work stat or whatever you want. So my thought is, hey, if I can't get this working, then I'll turn it into a CV controller and just use it for something else. Put some holes in the back, add some mini jacks maybe for the LFO out, for the CV pitch out, and figure out what I'm going to do about gate out. Truth is, the synthesizer does play. It just doesn't play very well right now because I'm having trouble with the sample and hold circuit and maybe with the resistor matrix. I'll tell you another modification that I'm probably going to do with the resistor matrix. You just don't need it. You don't need the resistor matrix, at least not the one that's installed in the Moog. This is a static matrix because this is a preset synthesizer. You push down a button, it turns on a set of preset resistance values which create voltage values, about a dozen. Okay, those dozen voltages are fed back into the synthesizer right here, frankly, and they affect the filters, the envelope, all the usual parameters that you would manipulate on an analog synthesizer by hand. My intention is to basically what am I going to do? Cut these wires here. No, I'm not going to cut these wires. Put in a different jack right here, a different Molex adapter, and have a new cable bundle attached to a bank of potentiometers with some biasing resistors. So the biasing resistors would take the voltage down to a safe level, the level that the Moog circuitry is expecting, and then some potentiometers for tuning in different voltage settings that represent all the different voltages that you could get from these presets, plus anything and everything else. So in short, turn the Moog into a non-preset synthesizer with a whole bunch of knobs for controlling all the different inputs to the circuitry, and it will make it a much more interesting sounding beast. So, control voltage, voltage divider circuit, and then it's just a matter of tuning it and plugging it into something that takes CV. And you can get something that sounds pretty cool.